Hi everyone, we are now in BIOrbit and we will show you now how to monitor green areas and detect forest coverage in those areas using our system. To do this, we will first connect our wallet. Once we do, the monitoring button will activate and we will find a short form to fill with the basic data of the area we're going to monitor. We will start with the coordinate section where we will need to have some. To do this, we will use getCoordinates, which will open a GeoJSON file. With a GeoJSON file, we can choose any area of the globe to be monitored. For practical purposes, we already have a predefined area, which is the Selva de Florencia National Natural Park, located in our country, Colombia. For this time, we will select a square and allocate the area to be monitored. Once we do it, it will give us the coordinates we need. Then we will fill in the additional data and start monitoring. Before it executes, we will need to pay the donation that virtually represents the cost of monitoring. While the transaction is running, you can see in this area how a backend is running that will be listening to the contract events when the transaction is completed. And the monitoring payment is made. Once this is executed, the monitoring system will start downloading satellite images. The area will now start its monitoring process. As you can see, the events have been received and a window will open for image downloading. For demo purposes again, we didn't activate the handless function so that we can see how the image download works. However, in production, this shouldn't be appear. Here we can view the designated area while observing how the build script works. We are going to test how we do the processing using the services of Bacalao. We already have an image that we created from our code in a container with Docker. And now we are going to run one of the tests so that we can see the result in the terminal. I'm going to run this one called JavaID2. At this moment, the image is being uploaded to the Bacalao services and the processing is being done. The processing basically consists of extracting the NDVI layer and also extracting the RGB matrices to create an image. And then, with a combination of the two, we can see the image of our NFT. We will wait a moment to make sure that it has already finished. And then we will copy the name that we assigned it. It has finished. Let's see our variable. Well, after downloading the images, let's see what was stored. So here we have our park. Here is the designated cover, the title, a brief description of what the park is, the country it's located in, and to view its NFTs. Before seeing everything, here we are looking at the relay that will process all the images, coordinates, dates, and times of image detection to see if the processing was actually completed. And we can see that the transaction was completed correctly. After storing the data and protection and information, now we are going to see what we are going to mint with the NFTs within the same relay. We can see here that the transaction that was confirmed is being minted and the hash is launched. Now it is being approved. it tells that the satellite image is for sale as an NFT. Now we will verify. Clearly, the blockchain takes a little time, so we may not find it at the moment. So we must refresh it again. And indeed, here is our NFT with ID 0 and the capture date. This is the satellite image. The green is forest, the brown or coffee color is not forest, and what you see in black are clouds that couldn't be corrected because there was no coverage in those areas during the entire image processing. But later, when an image without those clouds is available, that lack of information can be eliminated. And here we can see the dates on which each of its records was taken and the coverage, the amount of coverage per hectare of forest. Clearly, this is all, so we will proceed to buy the NFT. Now we will go to the OpenSea testnet. Here we can see the image item number 23. The others were other tests performed previously. Finally, we have our satellite image. And here is all the logic of our smart contract. Now we will see how the image processing backend of our project works. Once the satellite images are downloaded, we proceed to process them. The first thing we do is organize the data with the metadata to see the deforestation evolution over time. This graph is not shown in the front end, but it helps us to understand the data. Once the metadata processing is done, we move on to processing the images. First, we generate an image with a red-yellow scale using in the BI layer of the satellite. Red areas indicate higher NDVI, which means higher deforestation. Next, we use the remaining channels of the RGB cable to generate a color image that looks like a photograph. Finally, we combine the two images to create an image that closely resembles our NFT. After that, we proceed to upload the data. We upload the generated image to Estuary and store it on IPFS. We obtain a CID for the image and another CID for the metadata in OpenSea format. The metadata contains the CID for the image we obtained earlier. And this is how our entire backend works. Thank you so much.